Hello, it's November. Woo, I can't believe we've been in school since August already. It's amazing how time flies. First off, want to say a lot of people did really well with Tuesday's practice check, so that was very cool to see. A lot more level 4s than I've seen in a long time. Really nice work, everybody. Good effort. So today we've got three questions that all have to deal with equations for proportional relationships. So the first thing is I ask you to look at this equation and make a prediction about it. Do you think it's going to be proportional or not? Now, with a prediction, there's no clear right or wrong answer. You just need to be able to explain why. But I was interested in seeing if people used the conjectures that we developed on Tuesday and noticed that because this has this adding afterward, that would make us think that it's not going to be proportional because you're adding something extra in. So my prediction looking at this would be, no, it is not proportional. Because the extra plus 9 is added. So, but let's test it. I don't want to just trust its conjecture. I'm going to start with the most basic. What if x is 0? If x is 0, then times 4 and plus 9, well, 0 times 4 is 0, plus 9, y is going to be 9. Okay? If x is 1, 1 times 4 is 4, plus 9 is 13. If I go to 2, 2 times 4 is 8, plus 9 is 17. And 3 times 4 is 12, plus 9 would be 21. Well, this is nice. I know 3 times 7 is 21, so I just need to see, are all the other ones also being multiplied by 7? So our ratio y to x, in this case, is 7, but 2 times 7 is not equal to 17, so this is not 7. As soon as you see two things that are not the same, two ratios or two unit rates, then you know that this is not going to be proportional because there's no constant of proportionality, or COP, as people have been saying. Now, looking at this one, all we're doing is multiplying. So anything that is my x, for example, x is 1, I'm going to multiply by 5 halves. Since I have this rule, multiply by 5 halves, that tells me I do have a constant of proportionality. Constant of proportionality is 5 halves. So yes, this is proportional. Now, I do want to start us with the first 5, since we spent quite a bit of time thinking about this, and I think it's helpful as you move on. We have an original recipe for lemonade. 5 lemons, 2 cups of water, and 2 tablespoons of honey. I want to make a lemonade that is more of it, but it tastes the same. Well, in order to do that, I need to keep that ratio of lemons to water to honey equal to what it was before. That ratio needs to stay the same to the original in order for the flavor to remain consistent. So if I want to make more, one possibility, if I have 5 lemons, 2 cups of water, and 2 tablespoons of honey, would just be to double the entire thing. Now I have 10 lemons, 4 cups of water, and 4 tablespoons of honey. So if I could feed 10 people, now I could feed 20 because I've doubled it. I also could triple it. I could quadruple it. You can go on infinitely as many times as you wanted, and you could get it to be bigger and bigger and bigger. I could also do something like times 1.5. So that wouldn't be a full extra batch, but I still would have this scale factor. And people noticed that as long as you're scaling, that's going to keep it the same flavor. Now, if I want to make less lemonade, I need to think about getting these numbers to be smaller, a lower quantity. So if I have 5 lemons, 2 cups of water, and 2 tablespoons of honey, maybe I just cut it in half, divided by 2, which is the same as times 1/2. So now I would have 2.5 lemons, 1 cup of water, and 1 tablespoon of honey, and that would be one possibility. Someone noticed that I could divide the whole thing by 5, so if I used 1 lemon, which is nicer than 2.5 lemons, because then I don't have any lemon left over, then I would have 2/5 cups of water, and I would have 2/5 tablespoons of honey. Again, as long as we are scaling everything, we're going to keep the flavor the same. Now, if I want to make a stronger lemon taste, I need to make it more lemony compared to the water and the honey. So one possible way to do that would be to amp up the lemon flavor. So maybe I double the lemons, but I keep the water and I keep the honey the same. There's more lemon and the same amount of water and honey, so it's going to taste more lemony. So that would be more and the same. Another possibility would be to keep the lemons the same, but use less water and less honey. Because now I have the same amount of lemon and it's flavoring less stuff, so it's going to be more concentrated. And these are just two of an infinite number of recipes you could make. If I want to make a weaker lemon taste, well, if we started with this one where we keep the water and the honey the same, then I need to just use less lemon than I did before. Maybe I just use 1 lemon. Now it's way fewer lemons going in the same amount of water and honey. Or alternatively, I could say I'm going to do 5 lemons, but now I'm just going to use like 10 cups of water and 10 cups of honey. So much more liquid that now my same number of lemons are going to be diluted. Okay. All right, and then this is what we spent the bulk of our group work time on today. I have a scenario that does not have a question, and I wanted students to come up with a question that they could answer. So our scenario is that a company is hiring people to read through all the comments posted on their website to make sure they are appropriate. 4 people applied for the job and were given 1 day to show how quickly they could check comments. Alfie worked for 210 minutes and checked a total of 50,000 comments. Bertha worked for 200 minutes and checked 1,325 comments every 5 minutes. Carlos worked for 120 minutes at a rate represented by the equation C equals 331 times T, where C represents the number of comments checked and T represents time in minutes. And Delphine worked for 150 minutes at a rate represented by the equation T equals 3/800ths times C. And the goal, as I have written here, is to find a mathematical question that we could ask and answer about this scenario. I ran us through a 3 reads strategy. When you do 3 reads, you're looking at all the information you have and parsing through it. So on the first read, you want to know what's going on. And students variously noticed that we are hiring people. There are 4 people, 4 applicants. And they need to show how quickly. So they're showing their speed at reading comments. On the second read, I asked students to annotate quantities that seem like they might be important. Some quantities we might notice here. 210 minutes for 50,000 comments. So maybe a ratio of 220 minutes to 50,000 comments. For Bertha, we have 200 minutes, and we have 1,325 comments every 5 minutes. So the ratio here is 1,325 comments, 5 minutes to 1,325 comments, if we want to keep it consistent to the ratio up here, minutes to comments. 200 minutes might help us find a total, but if I'm just annotating my ratios, I'm going to keep those consistent. Carlos worked for 120 minutes at a rate represented by C equals 331T. This equation feels like it would be useful. And maybe this total time also seems like it would be useful. But we don't actually have a ratio yet. So we could notice that, well, if T is 1 in 1 minute, 331 times 1, we could do 331 comments. So a ratio we could write is in 1 minute. Carlos can read 331 comments. And then Delphine worked for 150 minutes, so a total again, at a rate represented by this equation, which is inverted from the, excuse me, inverted from the equation up here, instead of C being by itself, T is isolated. And so I might want to do something to get myself a minutes to comments just like I did before. It's going to be a little bit more challenging. And so that's something that we could come back to. So looking at this, several groups noticed that if you want to compare speed, you need to have one quantity to compare. Like you have to be able to compare minutes to minutes, for example. And a lot of people noticed that a unit rate would be helpful here. So we could say, what is Alfie's speed? How many comments in 1 minute? For Bertha, how many comments could she read in 1 minute? And the same for Carlos. And the same for Delphine. Did you guys notice it was A, B, C, D? That was me being clever. You guys thought they were really weird names. Okay, so if I want to find that, well, do I have any of that information given already? Alfie's in 210 minutes, so not 1 minute. Bertha is in 5 minutes, so not 1 minute. Carlos is 1 minute. Ooh, Carlos, 331 comments in 1 minute. Delphine, we've got some work to do with Delphine. So at this point, students had some different strategies for trying to get down to 1 minute. One that I want to highlight is using a table, because I saw people using tables in some really meaningful ways. If we have our minutes and our comments, we could start with Alfie and say that Alfie takes 210 minutes to read 50,000 comments. Well, we want to get down to 1 minute. So what can we do to get down? Any number divided by itself will get me to 1. So then I also would need to divide 50,000 by 210. 50 divided by 210. That gives me about 238. And I'm going to stay there for now because that might be precise enough. Definitely lets me compare to Carlos. So Alfie can do 238 in a minute. Well, Carlos 331, he can go faster. So he's definitely beating Alfie. Now let's look at Bertha. We do have a total time for Bertha, the 200 minutes, but we also have this ratio that's going to help us get down to 1 minute. In 5 minutes, Bertha can read 1,325 comments. So if I want to get to 1 minute, I would need to scale down by 5. And that's 265, exactly 265 comments. So she can do more comments in a minute than Alfie can, but fewer than Carlos. So now that leaves Delphine. Okay, so with Delphine, we have T equals 3/800 times C. Well, we know that we want our time to be 1 minute. So we can set 1, because that's the 1 minute, is equal to 3/800 times C. What kinds of numbers multiplied together get us 1? It has to do with reciprocals. If I were looking at 1/2, 1/2 times 2 over 1, that would get me to 1, because then I would have 2 over 2. If I did 1/3, I could multiply that by 3 wholes, because that would get me 3 over 3. If I had 4/5, and I multiply that by 5/4, now I'm going to have 20 over 20, which is 1. So if you flip them, then you end up with the same thing in the numerator and the denominator. So if I want my numerator and my denominator to end up being the same, then I need to multiply by 800, which would be 2,400, over 3. And we'd have, again, 2,400, which would be 1. So C would be the reciprocal of 3 800ths, or 800 divided by 3. 800 divided by 3 is 266.6 repeating, or 0.7. We can round that to 267 and say, well, Alfie loses. Alfie's in 4th place, 265. Bertha's in 3rd place at 265. Delphine is in 2nd place. Carlos would be the person that they would want to hire if they are only looking for speed. So in this case, looking for a unit rate was helpful, getting it all down to 1 minute. And that table is a nice way to organize your thinking so you know that you're getting down to 1 minute in a reasonable way. As you're looking at your homework tonight, these situations are not directly exactly like the problems we looked at today. For these, I want you to play around with what you know about proportional relationships. We've been working with it for a while. I want you to make some predictions. Here, explain whether you think this is proportional or not. Tell me, what do you think is going on if you have a stack of paper and the number of sheets of paper? So like if you had 1 sheet of paper, how much would that sheet weigh? You could even make something up. So then if you have 2 sheets of paper, how much would that weigh? Is that going to be proportional? Here, a stack of different sized books. Well, make some things up. If you have books and weight, if you have 2 books and one of them, they're different size, so one of them is like 3 pounds and one of them is 4 pounds, then you would have 7 pounds. What if you have 3 books, but one of them is 3 pounds, one is 4 pounds, and one is, I don't know, 5 pounds? So now we have 7, now we have 12. Is that going to be proportional? So I'm asking you to think outside the box, really apply some of these strategies that we've been talking about, and I want to see what you can do with it. Determine if things are proportional or not. Have a great night.